Hi everyone, Ms. Kilroy here. Today we will be going over changes of state. So if I'm ever going too fast, you can always pause and rewind. All you need to do is fill in the red blanks, but make sure you're listening because I will be providing important information. Okay, changes of state is the change of state from change of a substance from one physical form to another. For example, going from a liquid to a solid, freezing. Changes of state are physical changes because the identity does not change. So remember we talked about chemical versus physical change. Well, if we go from a liquid to a solid, liquid to gas, it's still the same stuff. So it's a physical change. You can go back and forth and not change the substance itself. In each state, particles of the substance move differently due to different levels of energy in each state. So for example, liquid water molecules have more energy than ice, a solid. So liquid has more energy because the liquid molecules move faster. The higher energy liquid water molecules can slide past each other, but lower energy solid water molecules, ice, can only wiggle in place. So with changes of state, we're either adding energy or we're removing energy in order to change the state. So we're either slowing those molecules down or we're speeding them up, basically through heat. Melting, you guys know melting, going from a solid to a liquid, melting chocolate. When enough energy is added to a solid, it will change state and turn into a liquid. As energy is added, particles move faster. In order to melt, the particles must absorb enough energy to overcome their attraction to each other. When they obtain enough energy to slide past each other or flow, the substance has melted to a liquid. Okay, so when you're melting chocolate, for example, you have the solid chocolate chips and they first must absorb enough energy and then the substance will melt to a liquid once they get more energy. Melting point, the temperature at which a specific substance changes from a solid to a liquid, so it depends on whatever the substance is. So water melts, right? Ice turns to liquid and liquid starts to freeze at 0 degrees Celsius, and gold will melt at 1062 degrees Celsius. So it can be a big difference just depending what the substance is. For example, you go on Pinterest and you find an idea and you test it out, and then your icing melts. And the butter solid melted to a liquid. Freezing, going the other way. Instead of going from a solid to a liquid and melting, this time we're going from a liquid to a solid. So it's the opposite of melting. When enough energy is taken away from a liquid, it will change state to a solid. And then this only occurs when the attraction among particles is stronger than the particle's motion. So the freezing point, the temperature where a liquid changes to a solid. So this is the same temperature as the melting point. So if this is the melting point of water, this is also the freezing point. Same with gold. So we're just going back and forth either from a solid to a liquid or a liquid to a solid. So the only difference between melting and freezing is if we're either adding energy, melting, or if we're removing energy, freezing. Okay, an example of freezing, we slowed down those liquid water molecules. They slowed down to just wiggle in place and they turned into a solid. So the water turned to icicles. Okay, vaporization, going from a liquid to a gas. Now, there's two types of vaporization and they're a little bit different, but this is the general term for evaporation and boiling. Vaporization is when enough energy is added to a liquid, it will change state and turn into a gas. So we're speeding up those liquid molecules, they're going faster, and they turn to a gas. Evaporation is when random particles in a liquid have enough energy to escape, and evaporation takes place at the surface of the liquid, and evaporation increases as temperature increases. Right, so if you're laying out at the beach after you jump in the ocean, you can kind of feel the water evaporating. So when it's hotter out, the evaporation will increase. You'll get more evaporation when the temperature is hotter. Boiling, another term for vaporization. Boiling is the change of liquid to a vapor or gas that occurs throughout the entire liquid. So boiling are all those bubbles, those gas molecules happening throughout the entire liquid, and evaporation only happens at the surface. The boiling point is the temperature at which a specific substance changes from a liquid to a gas. So water, we're very familiar that water boils at 100 degrees Celsius. It goes from a liquid to a gas. But gold, once it's a liquid gold, it'll turn to a gas from at 2,807 degrees Celsius. So it just depends on whatever substance it is. Okay, vaporization, like a steam room, you have all that gas. The liquid water turned to gas. Okay, so pressure, altitude, and boiling point. The atmospheric pressure, it depends on where you are in comparison to sea level. So when you're closer to sea level, there's more atmospheric pressure than when you're high up, let's say at Mammoth or Mount Everest. There's less pressure up there. It's caused by the weight or force of the overlying column of atmosphere above. So when you go lower, there's more stuff pressing on you. So it decreases with higher elevation. As you go up, there's less pressure. Lower pressure means a lower boiling point. So molecules can escape from the liquid state at lower temperatures if there is less atmospheric pressure. So food takes longer to cook at higher elevations because the temperature of the boiling water is lower than at sea level. So for example, when you do go to Mammoth, it's much, much higher up. Down here in Santa Barbara are, I'll write this down. I like blue. So here in SB, we're about at 0 feet, right? We're about sea level. And water boils at 100 degrees Celsius. But if you're in, I'll go to magenta. Mammoth, it's about, I think it's about 4,000 feet up. So much higher. And then so instead of boiling at 100 degrees, there's less pressure up there, so those molecules of the liquid can escape easier. So instead of boiling at 100, it'll boil at like 97 degrees Celsius. Okay? And the food takes longer to cook at this high place in Mammoth because the temperature is lower. So instead of cooking my pasta over here for 10 minutes at 100 degrees Celsius, because it's not as hot, doesn't boil at a higher temperature, it'll take longer. It'll take like 13 minutes to boil my pasta, to cook my pasta. Okay? Condensation, going the other way, going from a gas to a liquid. This is when enough energy is taken away from a gas, it will change state and turn into a liquid. For a gas to become a liquid, a large number of particles must clump together. And then the condensation point is the temperature at which a gas becomes a liquid. It's the same as the boiling point. So in boiling, we're going from a liquid to a gas, but condensation, we're going from a gas to a liquid. So that happens for water at 100 degrees, gold at 2,807. That's the condensation point as well. Okay, for example, you have an ice cold, we'll do iced tea. Ice cold iced tea on a hot summer day. You leave it outside and you can see that your glass is sweating. It's wet on the outside. Now this is not because there's a hole in your glass. It's because the gas molecules from the air that have hit the cold drink, the gas has turned into a liquid. It slowed down those molecules, air molecules from the outside once it touched the glass, and it turned into a liquid. So condensation is the outside air, the gas, turning into a liquid. So this water on the outside does not come from your iced tea or whatever drink you have on the inside. Sublimation. So this time we're skipping, we're going straight from a solid to a gas. So a change of state when a solid turns directly into a gas. Particles going from tightly packed to spread really far apart. So for example, dry ice. At room temperature, the molecules in the ice begin to move so rapidly that they escape the solid and become a gas. So we're skipping that liquid step. So we start from a solid where they just wiggle in place to adding so much energy so quickly they go straight to a gas. So dry ice, the solid to the gas. And then deposition goes from a gas to a solid. It's just the opposite of sublimation. This time we're removing energy. We're slowing these molecules down. And for example, water vapor can turn into ice or frost right away. So sometimes out on the field in the morning times in the grass when it's really, really cold, the water vapor from the morning, dew kind of thing slows down so much so quickly it freezes over. Okay, and then for this, why don't you guys copy this down to page 75. So this is for period 0, 1, and 5. Copy it down to page 75. Periods 2 and 3, why don't you copy this down to page 81. So what I want you guys to get at here, take out the whole page and you need to make sure that you write phases of water at the top. You write the T stands for temperature, so you can write out temperature, degrees Celsius, and then down here is the heat added. So here we have a solid, here we have liquid, and here we have gas. These horizontal spots is where the solid's turning into a liquid, and here is where the liquid is turning into a gas. So if we're going this way from left to right, going from a solid to a liquid, it's melting. If we're going from a liquid to a gas, it's vaporization, or like I said, boiling or evaporating. But if we go the opposite way, liquid to a solid, we're freezing. Okay, we're going the other way. We're slowing down molecules. If we're going from a gas to a liquid, condensation is happening. We're slowing down those molecules. So the red we are adding energy. So write this on here in much better handwriting somewhere on this page. And you might want to write red if you don't have a red pen. So adding energy, this will take a while. And then so we have to heat up our solid to turn to a liquid, we're adding energy. And then the blue, so going from a liquid to a solid, we are removing energy. We're slowing down those molecules. Sorry, everyone. And again, if you don't have these colors, you need to write that blue, or maybe you can just circle them. We'll do that. Okay, those are removing energy, while the other ones were adding energy. Let's see if I can teach you some new words too. Okay, so I'll go back to red. When we're adding energy, energy is entering. So it's endothermic. It's an O. Okay, adding energy is endothermic. Energy is entering, adding energy. And then when we remove energy, it's called exothermic. Energy is exiting. And the word thermic means heat, right? Like thermometer, thermals. Okay, removing energy, exothermic, energy is exiting. Okay, so these are your two new keywords. You just write that below the graph maybe. Hopefully it doesn't go overlap. All right, and that's it for today. Good job.